This video is about finding the centre of mass, and here we've got three masses, 2, 5 and 3 at these points. And to find the centre of mass, we simply do mass times distance in the same way as we do moments in M1, add them all up in this way, and say that's equal to the total mass multiplied by the vector showing this where the centre of mass is. So that 10 is the total mass, 2 plus 5 plus 3, and the centre of mass in the x direction I've called x bar, and in the y direction I've called y bar. So I can equate the y coefficients, which is a bit of a waste of time, because I get 2 times 0 plus 5 times 0 plus 3 times 0 is 10 times y bar. In other words, y bar equals 0. Not especially interesting. It's just telling us that the centre of mass is along this line. It's not up or it's not down. What's more interesting is to equate the x coefficients. So I get 2 times 3 plus 5 times 4 plus 3 times 6 equals 10x bar. 20 plus 6 plus 18, that's 44. So therefore 10x bar is 44. X bar is 4.4, so the centre of mass is at 4.40. That seems to make sense. 4.4 is about there. If we got an answer along here or over here, that wouldn't make any sense, but bearing in mind the vectors and the masses, then 4.4 seems to be about a sensible result. Here we've got a similar situation, but this time it's in 2 dimensions, but nevertheless we can use the same procedures. It's 2, that's the mass, and then the vector from the origin is 1, 2. Doesn't matter what order I take them in. I'll do 5 next. So that's 1, 2, 3, 4 along with 1, 2, 3 up. So it's 4, 3, and then it's 3 lots of 3, 1. The total mass is still 10, so that's x bar, y bar. So let's equate the x coefficients. And we get 2 plus 20 plus 9 equals 10x bar, which means x bar is 31 over 10, 3.1. Now let's equate the y coefficients. And we get 2 times 2, 5 times 3, 3 times 1 is 10y bar. So 4 plus 15 plus 3, that's 22, so y bar is 2.2. So the centre of mass is at 3.1, 2.2. Does that make sense? 3.1, 1, 2, 3.1, 2.2, it's round about there. That makes sense. It's nearer the 5 than the 2, but that makes sense because 5 is a bigger number than 2. So the centre of mass is about there. That seems to make sense. Now we're also going to go on and consider laminas. A lamina is an object which has one dimension very small compared with the other two. It's got a length and it's got a width, but the depth is very, very small. So there's an example of a lamina. This is why I teach maths and not art. But basically any shape which is very, very thin, here's a rectangular lamina, that's what a lamina is. And a lamina is uniform if its mass is spread evenly throughout its area. So what we're going to look at is various laminas. Clearly, if we have a uniform circular disc, then the centre of mass is at the centre of the disc. Centre of mass in the centre of the disc. And a similar thing for a uniform rectangular lamina. Just bear in mind that this is uniform, it means the mass is distributed evenly through the shape. So what about a triangular lamina? This is not what we were doing before, when we had three distinct points here, here and here. This is a solid shape. And where is the centre of mass? Where's the centre of this triangle? And the way to find this out is to add up the coordinates and divide by 3. So all we do for this is to find the coordinates of the corners of the triangle. So this point is at 1, 1. This is at 5, 0. And this point is at 2, 1, 2, 3, 4, 2, 4. And then divide that by 3. So that becomes 8/3, 5/3. So the centre of mass of this lamina is at 8/3, 2 and 2/3, that's about there. 5/3, 1 and 2/3, that's about there. So the centre of mass is at that point. Another thing that you should be aware of is that if we were to join each corner of the triangle to the midpoint of the opposite side, and then this point would go to, and this point would go to about there, then this point here is the centre of mass of the lamina. So it's joining the corner to the midpoint of the opposite side. Corner to midpoint, corner to midpoint. And we get the same result as we've got here. Now we're going to look at a uniform sector of a circle, just a part of a circle. And here we've got this diagram, and I've drawn in the line that cuts the sector into 2. Clearly the centre of mass is going to be along this line, but how far along this line? Well, it can be proved, but it's not part of the course to see this proof, that the length from the centre of the circle to the centre of mass is 2r sine alpha over 3 alpha. So if the centre of mass is here, then the length from O to G is 2r sine alpha over 3 alpha. Beware with this, that this is alpha is not the whole of that angle, it's half of that angle. So alpha is that half angle there.